Okay, in section 8.2, we're talking about arithmetic series and sequences. So let's talk about this for a second. If you remember in class, or if you weren't there, a series or sequence is a set of terms. The terms are all the individual ones, okay, individual numbers there. To determine if a series is arithmetic, you need to look at your first difference. If your first difference is your common difference, then the series is arithmetic, okay? So I created a table with n, meaning my number of term, so my first term, second term, third term, fourth term, fifth term. And then I filled in my terms, and I looked at my common difference. From 1 to 4, I'm adding 3. 4 to 7, I'm adding 3. 7 to 10, I'm adding 3, etc. So that is my first difference. It is also my common difference because they're all the same. They're in common. So D equals 3. That's how you determine if it's an arithmetic sequence. So what about if it's not an arithmetic sequence? Let's consider this case. The first difference here, 2 to negative 9, we're going down 11. Then up, 37, etc. It's not an arithmetic sequence, so we need to figure out what type of sequence it is. So again, I'm going to make a table. Got my n. The n is 1, 2, 3, 4, 5. If n is 1, my first term is 2. Second term is negative 9. Third term is 28. Fourth term is negative 65. And my fifth term is 126. Okay? First thing you need to do when you're doing these is look at those sign changes. I need to write an equation to take care of my sign change so that I don't need to concern myself with it. So that's always negative 1 to the power of n, maybe. If n is 1, I want it to be positive, right? So if I have negative 1 to the first power, it'll be negative. So I'm going to do n minus 1. So if n is 1, it's to the power of 0. Anything to the power of 0 is 1. If n is 2, 2 minus 1 is 1, so that makes it negative. So I'm going to do this times the rest of my formula. Okay? So now I don't need to worry about the sign changes. Now I'm going to look at my my differences. My first difference. Going from 2 to now just 9, because I've already accounted for my sign change. 2 to 9 is a change of 7. 9 to 28 is a change of 19. 28 to 65 is a change of, let me grab my calculator really quick. It's a change of 37. And then 65 to 126 on the calculator says it's a change of 61. So since this is my first difference, we know that it is not arithmetic, because if it was, my first difference would be my common difference, right? So let's look at our second difference. 7 to 19 is a change of 12. 19 to 37 is a change of 18. And 37 to 61 is a change of 24. So again, our second difference is still not our common difference. Okay, so we're going to look at our third difference. 12 to 18 is a change of 6. 18 to 24 is a change of 6. So that's where we see it in our third difference. That means that this function right here that we're working on has to have a cubic in it. It has to have it to the power of 3. So we're going to look at that. We have negative 1 to the n minus 1. We've already figured that out. That accounts for our sign change. So to find our cubic difference, consider our n's. If n is 1, what is 1 cubed? 1 cubed is 1, okay? And then change our sign. Well, that's not working. We need to add 2, because this would still be, if n is 1, this would be 1, so it's all still the same. So we need to take our n, cube it, and add 1, right? Let's check and see if that works when n is 2. If n is 2, 2 cubed is 8, plus 1 is 9, And then this 2 would make it negative. So it works. That's our function.